In case you don't remember how to factor, we're going to review basic Algebra 2 factoring, actually Algebra 1 factoring as well, that you should have learned in high school. So, the steps you follow. First, no matter how many terms you have, always check to see if there is a greatest common factor. As long as the GCF is greater than 1, you want to factor it out at the very beginning before you do anything else. After you check for a GCF, then your factoring approach is based on the number of terms that you have in the expression. If there are 2 terms, check first to see if you have a difference of squares. So ask yourself 3 simple questions. Is the first term a perfect square? Is the last term a perfect square? And is the sign in the middle subtraction? If you can get a yes to all 3 of those questions, then you will have a difference of squares, and it factors in this form. A squared minus b squared. First term was a perfect square. The last term was a perfect square. The sign in the middle is subtraction. You will open up 2 parentheses. Take the square root of the first term, put it in the front of each parentheses. The square root of the last term goes at the end of each parentheses, and then 1 parentheses gets a plus and 1 gets a minus. The order you put them in will not matter. Now, there are other patterns that do factor for 2 terms. You can have sum of cubes or a difference of cubes. We won't be working with those in this course, so I have not included those in your factoring review. If you have 2 terms, the only thing you would need to check for in this course is to see if you have a GCF, and then check to see if you have a difference of squares. And we'll do some examples of these in a moment. If you have 3 or more terms, you want to try to factor by grouping. Now, when I say 3 or more, I really mean 3 or 4. We're not going to look at how to factor something that has more than 4 terms in this course. If it's 3 terms, if it's a trinomial, remember that if you rewrite the middle term in such a way that you can get it to factor by grouping, that would be a systematic, easy way to factor. We teach it as something called the AC method when we teach it in intermediate algebra here at the college. And if you know how to factor a different way, I want you to be aware there are other ways to factor, and it is perfectly okay to use a different method. But if you've never understood how to factor 3 or 4 terms, this will work every time. It's very systematic. I'll explain it, and then we'll practice with a few problems. You want to take the coefficient of the first term, the number in front of that first variable that has the square on it, multiply it times whatever the constant at the end is, the last term. That's why we say A times C. And you need a pair of numbers that would multiply to give you that value, but add up to give you whatever the coefficient of the middle term is, the B value. So for example, if we were to look at 2k squared minus k minus 6, I'm going to need a pair of numbers that would multiply to give me the A times the C, which is 2 times negative 6, or a negative 12. But it has to add to give me the negative 1, which is the B value. Notice that it's right in front of the K, and I didn't see a number there, I just saw the negative sign. Remember, if you don't see a number, there's a 1 that's a coefficient, so that's why it has to add to give us negative 1. The pair we need is negative 4 and a positive 3. Now, it's ready to factor by grouping. Let me show you how this works out here to the side. If we take 2k squared minus k minus 6, and we have determined the pair we need to use is a negative 4 and a positive 3, we are going to rewrite the middle term as 2 terms. So we're going to have 2k squared minus 4k plus 3k minus 6. Now, we look only at the first pair, and we factor out the greatest common factor. So in 2k squared minus 4k, my GCF is 2k. That's the term that would divide into both 2k squared and 4k evenly. So if I factor out a 2k, I'm going to open parentheses. 2k times k gives me 2k squared, minus, if I multiply 2k times 2, I'll get that minus 4k back. Okay, so double check yourself by using distributive property to be sure when you multiply back you get the original. Match the sign that's in the middle. In this case it's a plus sign. Now I can take the GCF of the last pair. So that's going to be 3. Write it down, open a parentheses, and again do backwards distributive property. 3 times what gives me 3k? I need a k. And 3 times negative 2 will give me the minus 6. Now, when I have finished, notice I have written this now as a pair of terms. There is one plus sign separating these two terms. It's just that the first term is now in factored form, and so is the last term. And what I'm hoping will happen, and it has happened in this case, my parentheses match. That gives me a new GCF. So I will write down that parentheses as my common factor, and my second parentheses will be these leftover parts that were the GCF in the last line. So when I open my second parentheses, this k minus 2 has to get multiplied by the 2k, and k minus 2 has to get multiplied by the plus 3. And that is now the factored form for our original trinomial 2k squared minus k minus 6. Don't forget, you can always check your factored form by multiplying these two parentheses back together to make sure you get the original. Now, let's do a few example problems to make sure we're comfortable with this. If you look at number 1, it doesn't matter how many terms I have, I always check first for a GCF. And so there's only 2 terms here, 8x, and then I have a minus sign in my second term. Following the minus sign is the 80. So my GCF is 8. If I open a parentheses now, this is backwards distributive property, factoring out the GCF. Inside I would have an x, because 8 times x gives me 8x, match my sign, and 8 times 10 gives me 80. And if I look at my parentheses, there's no way that x minus 10 can factor any further. There is no more GCF, and it's certainly not a difference of squares. So I am done. Now, if I look at number 2, don't forget, the first thing you check for is what? A GCF. So I notice 2 is going to go into all of these terms evenly, but also notice I have x's for all of the terms. Now, my exponent that is the smallest will be my GCF. Notice I have an x to the third, an x squared, and just a plain x to the first power. So 2x becomes the GCF. Has to be the one with the smallest exponent. Open my parentheses, and inside the parentheses I will write what is needed so that when I use the distributive property I'll get the original back. So 2x times x squared is how I would get 2x to the third, match my sign, plus 2x times 5x is how I get 10x squared, minus 2x times 1 would give me the last term. And if I double check my parentheses, I'll notice there are 3 terms there. I might need to consider that this could continue to factor using the AC method, but if I do a quick check, my A times my C is 1 times negative 1. Is there a pair of numbers that multiplies to give me negative 1 but adds to give me 5? No, that's impossible. So at that point, I would say I am done. Let's look at number 4 on this example sheet now. 8t squared minus 13t plus 5. Now, remember, check first for a GCF. In this case, there is nothing greater than 1 that goes into 8, 13, and 5 evenly. So we're going to try the AC method. If I multiply the A times C, that's a positive 8 times a positive 5, which is positive 40. So I need a pair of numbers that will multiply to give me positive 40, but add to give me this b value, which is negative 13. Remember, a sign in front of a number stays with the number. So what I know is this: if I have a pair that multiplies to give me a positive, that tells me that they have the same sign. They're either both positive or they're both negative. If they're going to add to give me a negative 13, that tells me they have to both be negative. So I'm looking for a negative number times a negative number that's going to give me 40. The pair I need is an 8 and a 5. If I multiply those, I get positive 40. If I add negative 8 plus negative 5, I get negative 13. Now, you may instantly know the pair in your head, or you may want to make a list. You could list 1 and 40, 2 times 20, 4 times 10, until you come up with the correct pair. The order you write the numbers in doesn't matter, but that tells me that's the pair I need to replace my middle term. So I'm going to rewrite this as 8t squared minus 8t minus 5t plus 5. Now that I have 4 terms, I can factor by grouping. If I look at the first pair, the GCF would have to be 8t. That means when I open my parentheses, 8t times t gives me 8t squared minus 1. So that 8t times negative 1 gives me negative 8t. Now remember, I said match the middle sign. I'm going to want to put a negative sign down, and now when I look at my last pair, my GCF is simply a 5. So my negative 5 is actually the GCF I factored out. My GCF should match whatever the middle sign is. And that would mean in parentheses, negative 5 times t gives me negative 5t. Now this one, be careful. A negative 5 times what gives you a positive 5? In order to get a positive, I need a negative times a negative. Signs will be the most challenging part on this factoring for most people. You have to be very confident in your sign rules and make sure that when you use the distributive property, you see that you're getting the correct sign back. And when I factor it this way, pulling out the GCF, I see my 2 parentheses do match. That means t minus 1 is my new GCF. My other parentheses will contain 8t minus 5. Let's look at another example. Let's skip on down to number 6. You have 4t squared plus 1. If I'm looking for a GCF, do I have one other than 1? And the answer is no. That means I'll check to see if this is a difference of squares. Well, the first term is a perfect square. I can take the square root of 4t squared and get 2t. The last term is a perfect square, so I get a yes on that. But is the sign in the middle subtraction? No. And because that was a plus sign, that means this is not factorable, or you could just write the word prime. Prime is another way of saying that it can't be factored. And that happens sometimes. So we have to be certain that we're aware of that and paying attention to it. Now, if you look at number 7, it's another one with 2 terms, and when I check to see, do I have a GCF other than 1, the answer is still no. But now when I ask the questions, is the first term a perfect square? I get a yes. Is the last term a perfect square? I get a yes. And this time, is the sign in the middle subtraction? Yes. That means I'm going to open 2 sets of parentheses. The square root of the first term goes in the front of each parentheses. The square root of 36x squared is 6x. The square root of y squared is y. That goes at the end of each parentheses. One gets a plus, one gets a minus. And if I wanted to multiply these back together to check my work, I would see it actually gives me the original back. Let me show you very quickly, in case you have forgotten, how you can multiply a binomial times a binomial. It's easy to set it up with a box. I'll take, since there are 2 terms in each parentheses, I'll make a box that's a 2-row by 2-column box. I can put 6x plus y across the top. I'll put 6x minus y down the side. And now when I multiply, I'll put the answer to the product in the box where the row and the column intersect. For example, 6x times 6x, the answer goes in this first box. That's 36x squared. 6x times positive y goes in the top right box. That's plus 6xy. 6x times negative y is a minus 6xy, and that goes in the bottom left. And a negative y times a positive y is a negative y squared, and that goes in the bottom right. Now, what happens when I try to combine like terms, I have a positive 6xy plus a negative 6xy. They're going to cancel out. That's how this is a difference of squares. The plus sign in one parenthesis and the minus sign in the other, since everything else is identical, causes those middle terms to cancel out. And it does equal 36x squared minus y squared. Let's do a quick review of solving quadratic equations. Notice we just factored expressions. There was no equal sign. If you look at these problems down here, you now have equations. Now, we talked about the a, the b, and the c value before. Notice when we have standard form, it means that everything is on one side of the equal sign in descending order. That's why the a is in front of the x squared. It should be the first term we see. The b is in front of the x, the middle term. The c is the constant at the end. Make sure it is set equal to 0 before you solve. And the idea in solving is if I have 2 parentheses multiplied together that are set equal to 0, that means there are 2 numbers. I just don't know what they are yet because there's a variable in there. But 2 numbers multiplied together to equal 0. The thing that has to be true is the only way I get 0, at least one of those numbers had to equal 0. So for example, if you look at this number 3, x minus 5 times x plus 2 equals 0, what that tells me is the only way this can be true is if either the first parentheses, the x minus 5, is equal to 0, or the x plus 2 would have to equal 0. There is no other option for this to be true. And now I have 2 simple linear equations to solve. All I have to do in the first case is add 5 to each side. That would mean either x is equal to a positive 5, or in the second case I subtract 2 from each side, and x could equal negative 2. If I have an expression that is not already factored, such as this one on D, but it is all set equal to 0, it's ready to factor. So I simply use that AC method. I'm going to need a pair of numbers that multiplies to give me 1 times negative 10, which is negative 10. But it has to add to give me this middle term where the coefficient is a negative 3. Well, the pair of numbers I can multiply to get a negative 10 and add to give me a negative 3 would mean to multiply to get a negative, one number is negative, one number is positive, and the correct pair would be a 5 and a 2. I want to make the 5 the negative number, the 2 the positive, because if the larger number is negative, when I add them together, my answer will be negative. Now, for those of you who know a little bit about factoring already, there's a shortcut we can use on this one. As long as the a value is 1, the pair I come up with here is actually going to be what shows up in the parentheses when it's factored. So this is going to factor into m minus 5 times m plus 2. And it's still set equal to 0. All I did is factor the left side. So that means if I set each of these parentheses equal to 0, m minus 5 equals 0, or m plus 2 equals 0, I'm going to come up with m could be a positive 5, when I add 5 to each side in the first parentheses, or a negative 2 if I subtract 2 from each side in the second parentheses. Now the only thing that's different on one like F, notice it is not set equal to 0. Don't try to factor until everything is on one side and 0 is on the other. So the first thing I'm going to have to do is subtract 42 from each side, and that would give me 4x squared minus 2x minus 42 equals 0. And now I would factor as I would any other factoring problem. Look first for a GCF. In this case, you have one. You're going to need to factor out a 2. And then what's left in the parentheses will factor further. We will practice this in class, but I wanted to give you a brief reminder of how to solve quadratic equations.